Hello, I'm Robert, fact-checker and science blogger for Doomsday Debunked, where I'm helping people who are scared of various things. And this is about those of you who are scared that the news stories we get about us being in the middle of mass extinction. And we're not. If you read the actual science, then we are at the very start of a mass extinction. It's quite a big distinction. So I'm going to talk about that. The difference between being at the very start and being in the middle of it. And human beings ourselves, we are of least concern. I recommend the IUCN Red List as the best place for finding out about extinction risks. And we are of least concern, grassland. Look at all these habitats we can live. And that's not including the seashore, grassland, forest, shrubland, desert, rocky areas. We're one of the most versatile animals there is, even without our technology. And with our technology, we can even go live in space and live at the bottom of the sea if we so wish. It's quite amazing what we can do. So we are increasing and we are of least concern. There's no risk of extinction at all if you ask the proper scientists about that, not for human beings. So now what about the other species though? And then of course we worry about those. Well, and so a lot of people, so I'm just going to come down to the this little thing about, no, where is it? Yeah, this diagram. So this is the what is it? Well, let's read the caption properly and get it right. Yeah, so this is an estimate of how many years it would take to get the same number of extinctions as in the 114 years from 1900 to 2014, the background extinction rate. So instead of 114 years, so these extinctions in 114 years, and with amphibians, it's somewhere between 2,000 and 10,000 years of extinction that we've had in just a little over a century. And for mammals, it's between 2,000 and 6,000 years of extinctions. So vertebrates, generally, then a bit over 2,000, a bit over under 5,000. So the frogs are the most important, the high estimate of the frogs is very high. And that would be 100 times the natural extinction rate. And that's a conservative estimate. And so this is very, very fast. But now think about it in terms of the archaeological record. And if you're looking at what this century, but suppose it happened, say, 10 million years ago, and you look at the archaeological record, and some little frog there, and you're trying to work out when it went extinct, and you're not going to have samples of all the habitats that this frog was in. And it could easily have lingered for another 10,000 years and you just wouldn't know. Because you don't have a sample of that habitat. Even 100,000 years could have been there in some little puddle in the rainforest somewhere. So we just don't have the resolution. If you're looking 10 million years ago, you wouldn't even see this. You wouldn't know if those extinctions had taken 10,000 years, 100,000 years, or a century. So that is the sense in which it's only the very beginning of a mass extinction, because you literally would not see it in the fossil record. You wouldn't see any extinctions because you wouldn't have the time resolution. So if someone says we're in the middle, well, no, it's not even something that would register yet in the fossil record. And you can see that also from the number of species. Does this come up? Yes, it does. So if you look at the number of species of the vertebrates, we've had 477 since 1900. But look how many there are in total, 39,000. So if you go back, say, 10 million years, and suppose there were 39,000 species of vertebrates, and then 400 went extinct in 1 century, 500 went extinct in 1 century, you literally wouldn't notice it. Because you don't have the time resolution. you see, you might even not even notice that anything has happened at all. And maybe you've not even got fossils of some of those species at all. You wouldn't have all 39,000 species. You wouldn't have fossils of everything. And so, that's the sense. Then you mammals, you've got 5,069 went extinct, 111 since 1500. Again, and that's just a tiny blip out of the 5,500. And birds, very small percentage, 80 out of 10,000. And so on with all of them. And none of them do you have an actual figure that would be really amphibians, again, the most noticeable, 146 out of 6,414. And if that extinction rate continues for another century, again, you're not going to notice it. Not in the fossil record. Even 3 or 4 centuries like that, you just wouldn't notice it. So that is the sense in which we are not at present even, we're just at the very, very, very start of what would become a mass extinction if it continued like this for several more centuries. And like 1,000 years of amphibians, then 20% of them would be gone, and that would be very noticeable. But 1 century, it's not very noticeable. So I'm not saying that everything's fine and everything's wonderful. I'm just saying, to put it in perspective, it's not a mass extinction. We're not going to suddenly look around in 2100 and see that there are no bird species left, or there are no tree species left, or anything like that. Or no insects. I mean, the insects have a much lower rate than any of these. The rate of extinction of the, in terms of the percentage of insects that are going extinct. And so, and I worked out the extinction rate there just from there, 114 years, and multiplying it to get a century. So you've got 2% for amphibians. People ask about the killer frog disease, and this is actually one single fungus caused more extinctions than any other known diseases. Similar in scale to extinctions by predator mammals such as cats and rats. But we've conserved this species, although it's extinct in the wild. In some areas, then they actually are getting over this extinction, the disease, and they're recovering and they're starting to bounce back. There are a few places in the world it hasn't got to yet, but basically that's an old story that we've come to the end of it, and most of the extinctions happened last century. Its declines peaked in 1980. So that's including that 2%. And we're not suddenly going to get all the amphibians go extinct because of that disease. And so then you look at how many, what percentage are actually endangered. Then this endangered, people sometimes get confused between endangered and what's the other one? What the I get mixed up as well. I have to mind myself. So endangered, this is vulnerable, threatened. Endangered and threatened, that's the word. So it's very confusing. I get confused myself. So this yellow means threatened. Oh, no, yellow means vulnerable, and orange means endangered, and red is critical. And vulnerable and all of those are referred to as threatened. It's just kind of language that they use for the IUCN Red List. And the vulnerable, which is the least at risk of threatened, then that can be a 10% chance of extinction in a century, or it can just be a very small population that is spread, or a fragmented population, even if it's growing. So these are definitely not all going to go extinct by 2100, even if we don't do anything. And the orange ones, it's still a percentage thing. It's decades and it's another percentage, and then the red is another one. But then they all have a criteria of thousands of individuals, that if it's below a certain threshold, then it goes in there no matter how even if it's increasing. So, if you look at it then, so for instance for birds, then if you look down there, that's near threat, and these are the only ones that actually have any kind of risk of extinction or very small populations. And it's just most of them these are least concern, and all these green ones are least concern. So again, I think few people actually realise that we have such large numbers of species that are just least concern. Now, clearly, it's a bit more than just the projecting forward of these numbers. There's some risk of the extinction rates going up higher as we get towards the end of this century. So we absolutely have to stop that. And but it's not a risk of still would you hardly notice it in the fossil record. But the other thing is that we are actually doing a lot in the other direction, and we're saving species. So I've got a couple of things up here. So what was it? The giant panda has gone from endangered to vulnerable, and that's a lesser thing. And then the humpback whale has gone from vulnerable all the way to least concern. That was in 2008. So in 2008, the humpbacked whale was, it would be a mammal. Where is that? Mammal. So in 2008, then it was vulnerable, and now it's moved all the way to least concern. It's somewhere here. So the world is not going to be one without humpback whales. And that's definitely going the right way. And a panda, I mean, you can't see it being in a world without pandas. They've figured out how to keep them in captivity now with great difficulty. And there are quite a lot of baby pandas bouncing around in Chinese zoos. There are less of them around the world. And they're still there in the wild as well. So it's now downlisted to vulnerable. And there could be kangaroos, bears, all sorts of things in the future. So, but it's not only that. There's much we can do to stop it from going that far. And the IPRES report, that's the 2017 report. It's a much later one. I may have to update this. Yes, here we are. Let's save 1 million species and make biodiversity great again. So this was the one that was shared last year, where all the papers were shouting out, 1 million species are going to go extinct. The actual message was, we can save 1 million species. And what's more, we know how to do it. And we know not just scientifically, but politically, in terms of sociology, in terms of the kind of measures that we need to get governments to pass, and that they can actually be persuaded to pass. It's a practical, worked out way to save 1 million species. 1 million species, those include ones that are just insects and little creatures in the sea. So when I said 1 million species, there aren't enough mammals and birds and things to make up 1 million species. It's including lots of tiny little creatures as well. And that them being at risk is that 10% by 2100 level of risk. So that wasn't made clear. We don't have 1 million species that are going to go extinct very imminently. And they'll include lots of myriads and myriads of insects. Anyway, so, but we can save them. And we can do that at the same time as feeding everyone, improving the efficiency of agriculture, circular economy. So the question really is, we can feed everyone through to 2100, whatever. There's no problem producing enough food for everyone. The challenges, but we can rise to them. But the question is, can we do it in a sustainable way or non-sustainable way? And a sustainable way with a circular economy and preserving nature services, then this is good for humanity, it's good for economically, it's good for GDP, and it's good for the planet, and it's good for species, and that's what they found out in a very big, extensive study. So we can do this, and that's the whole point. So we are at no risk of extinction. There's some iconic giant pandas aren't at risk, and koala bears are not at risk. They're not going to go extinct, even though they're technically counted as vulnerable, but it's somewhat political counting them as vulnerable. They're not really at risk. They're slightly just on the very, very edge of vulnerable, and there was some political pressure to count them as vulnerable so they get more protection. And the local populations are at risk, but not the entire species. And that's another thing. I just want to say a little bit about that. So, subpopulations of some subpopulations of koalas are definitely at risk. The whole population, not really. As it gets drier, and they'll just move further south, and then some of them will appear there, and even in Tasmania, I think they're going to move. They have to move a little bit as the climate dries up and gets a little bit drier in their traditional habitats. But they're not going to go extinct in the wild. And this is it's rather similar with the red squirrels in the UK, for instance, and that counts as threatened in the UK and vulnerable because it's quite a small population and it's fragmented. But the population of red squirrels in the Isle of Wight, and that's very secure, it's not going to go extinct. And the population in northern Scotland is also pretty strong, and they have to do various measures to kind of protect it and make problems with the grey squirrels and so on, but they're dealing with that, and it's not really significantly at risk. It's just that 10% by 2100, or it's a small population fragmented. But the most important thing is, that I just want to bring up here, is the red squirrels are no risk at all of becoming extinct in the world as a whole, because they're all over Europe, a vast area of red squirrels. And it's sad if they did disappear from the UK, but there are lots of, you often get these stories and say, such and such a thing is, and they just kind of fudge it, or they're not very clear, don't explain very clearly, and many people mightn't actually know that the red squirrel has such a widespread habitat. There isn't a risk of it going extinct in the world. And so the same as with the koala bears, then there are in Australia this risk of some subpopulations disappearing. There isn't really a risk of koala bears as a whole, of koalas going extinct. And so it's quite a lot of things like that. So now another thing I want to talk about is, well, first of all, we are very, of course it's of course important to keep all the species. Even we've got 33,000 whatever it was, 33,000, was that the mammals? 33,000, losing 500, it's not, I'm not saying it's okay. 39,000 vertebrates and 5,000 mammals, and losing 69, it's not okay to lose 69 mammals. It's not okay to have to lose as many in a century as we normally lose in perhaps 10,000 years if you go by the upper estimate, and the still quite conservative. That's not okay. I'm not saying it's okay, but it's not what the media make it out to be, and we can stop it. So so every species has value. They're like a treasure house, and the world will be poor without the golden frogs or whatever it is. And sometimes, like the species with unique, like the gastric brooding frog, I'm not sure what its status is. Let's look up the gastric brooding frog. I wonder if you've heard of this. The gastric brooding frog, it's been listed as extinct because it's not been caught in the wild And yeah, so that is extinct. So that I thought it was. I just didn't want to actually say. I have sometimes said mistaken things in these videos, so I'm being much more careful now to be absolutely sure. So this was the only two species, both of which became extinct in the mid-1980s, and it was the only two known frog species that incubated their tadpoles in the stomach of the mother, which is quite remarkable. So instead of leaving them in a pool, they kept the offspring in their stomach, where normally they'd be digested. And this, very sadly, no longer is with us, and we never will be able to completely disentangle the mysteries of the gastric brooding frog with our modern technology and understand how everything worked, because it's no longer here. The world no longer has frogs that brood tadpoles in their stomachs. So that is a unique thing that we've lost, and that's very sad. I mean, who knows what scientific ideas could come from that? Who knows, maybe even some technological things, and just a wonder of nature that the world used to have these frogs that had their tadpoles living in their stomach and not digesting the tadpoles. Some remarkable change in their stomach so they could have tadpoles inside. And we just can't. We just don't have them anymore, and there's no way of ever studying them now, because they're gone. That is very sad. So I'm not saying that it's good to lose species. They're unique, and there are all sorts of unique things that are out there, and we don't want to lose them. So, but we have, of course, lost lots of species in the past, and all those mammals that have been lost in the past from 1500 onwards and before then. There have been many mammoths and things like that. You all know about the dodo and whatever, but we've lost so many species already, even though they're only a tiny fraction of the whole. So we want to stop this and put an end to this. So absolutely. And we can do it. Now, why am I talking about dinosaurs here? Anyway, well, I think I'm just talking about how we're all the yes. So the world, yes. But it'll lead into the next bit anyway. So I'll just talk about this. So back at the time of the dinosaurs, all the continents were jammed together like that. Through the three periods when the dinosaurs were around, and the world was very conducive to the dinosaurs. There was very little change in temperatures compared with nowadays. A warmer world, no land near the poles, no polar ice caps, and a world which didn't really know winter, basically a tropical world. And then they were very vulnerable because they got the asteroid impact, the impact winter, the fires and everything. But there were survivors, and we are the survivors from them. And these little creatures. And then the turtles and so on and everything. So, but we don't face anything like this. We know what the causes are of the current fast extinction rate, and they're not able to lead us to mass extinction. In fact, they couldn't, because we have all those ones of least concern, and they wouldn't be, we're talking about a world in which entire groups of, nothing like the dinosaurs anyway. There's people vary in how they understand what is meant by mass extinction, but if you're thinking about one of the really big ones like the dinosaurs, we're not headed that way, because we have all these ones of least concern, and they're not going to go extinct. And if it was like the dinosaur extinction, then for instance you might lose all the birds, and there just is a world without birds. That's not going to happen. Or a world no longer has mammals, or no longer has sharks, and no longer has conifers. that's be a proper mass extinction. We're certainly not going through anything like that, no matter what happens. Even the worst case, even if nobody did anything, any conservation from now on, and we didn't do anything to stop climate change, we're not headed for a mass extinction in that huge sense of losing an entire big group like all the conifers gone or something. So that's not going to happen. And this is all about climate change. I've talked about that before. And this is about how we can't, our domesticated animals can't go extinct. Like our sheep, cows, dogs, cats, pet rabbits, goldfish, all the plants you grow in your garden, and the flowering plants and things, asparagus, carrots, peonies, beetroot, potatoes, whatever, they're not going to go extinct. Because we could grow them, we could grow peaches on the moon. So we can certainly, this is from a very charming Russian movie about the moon made in 1965. So we've never actually done this. But the technology is there, and if we really, really wanted to do it, we could certainly grow peaches on the moon. So we could certainly grow it without any atmosphere and with artificial lighting needed because of the 14-hour night, 14-day night. So there's a 14-day night. So there's no way that we're going to lose these things, not if we want to keep them. So we can do it on Earth far easier than on the moon. Nothing could make the Earth as uninhabitable as the moon. So that's one reason it can't be a mass extinction, because we'll preserve things that are important to humans and many animals and plants and things. And there's no major ecosystem goes extinct except potentially the corals. And again, you would hardly notice in the fossil record, and even deep water corals, they don't go extinct. The corals, I should say, the corals in the Red Sea, they don't go extinct either. And there'd be some heat-resistant corals even in the Barrier Reef that would still be there. There's a branch coral in the Barrier Reef, for instance, that would be identified that would still be there 3 degrees and above, because it's heat-resistant unlike the other ones. And then they might adjust. Nobody knows quite how well they're going to adapt, the other ones. And so, but another thing that's very interesting is that many ecosystems are actually becoming more diverse. And we're starting off with the world, so back then when everything was one island, back here, then the world, creatures could just wander from one side of landmass to the other, and there'd be mountains and things knocking their way a bit, but we are much more diverse than it was back then, when basically it was just one continent, one very, very, very big continent. And there's Chris Thomas as a biologist, and he says the analogy of what's happening today is like these colliding continents. So our continents are not colliding like they did back then, but we are moving things from one continent to another very much as if they were touching each other. And so you get these invasive species around the world, but you also get species coming in that don't do any harm at all. And actually, most species are not harmful, and they just enrich the ecosystem that they come into. And so he argues very strongly in his book that I recommend you read, and it's a very interesting slant on this. So again, not saying that any of this is desirable, but just look at it in another perspective, that what we are actually doing is here we are, how nature is surviving in an age of extinction, inheritors of the earth. So some, at least of the extinctions, are because of invasive species surviving in another, and there's fewer species overall in the world, but often, paradoxically, more species in each ecosystem in the world. So ecosystems are getting smushed together and there's less difference between them, but each little patch of it, there's more of it. And the UK and then human beings are actually adding to the diversity. So here I'm in the UK, and we're a great example of a country where there's far more biodiversity because of humans than there would be if we've never come to the island. Because the UK, well, first of all, it was covered deep in snow. deep in ice, kilometres deep. And when that cleared away, then there was pasture and tundra, and then there was forest. And the forest covered the entire planet, the entire country, and that was about it. And a bit of grassland here and there, and nothing much else, and some rocky crags. Then humans came along, and we cut down lots of trees, and we dug out our quarries, and we built our houses, which are homes for some creatures such as pigeons and falcons. And the quarries and lots of rare creatures in the, and then we cut down the trees over the, for instance, the chalkland downs, which is a very unique habitat with lots of grassland species. But it would have just been trees back then. And so all those habitats and the coppice woodlands and water meadows, where coppice woodlands with trees that were constantly cut down in order to make narrow poles for baskets and things like that, for basket weaving. And then you have the water meadows, which is where they flood every spring, and it's just they're by the sides of rivers, and they have very special plants that grow there. And all those habitats, they just wouldn't exist without humans. So, and it's the same thing is happening in Brazil, with it's rather different because the rainforest is so patchy, so you have little species that are only in little patches of the rainforest. But apart from that, it's very similar to what happened in the UK thousands of years ago, that they're cutting down quite a lot of forest. The entire UK was covered in forest. Now there's very little forest left of the original natural forest. And Brazil is in the process of doing something similar. And so they quite rightly look at the UK and say, oh, but we're doing what they did thousands of years ago. But it is very important, very different, because it's such a rich ecosystem and so many species with such small range. So I'm not saying again that we should just say to Brazil, go ahead and cut your trees down. We shouldn't. We've got to stop the felling of the Amazon rainforest because it's so biodiverse. And luckily, there are many ways we can improving the agriculture of Brazil, and that's one of the ways that we can. That's following the kind of approach of this IPBES, then improving the agriculture, making things better for the farmers, the more efficient their agriculture and circular and everything, circular and sustainable, and preserving nature services, and that's best for everyone. It's best for their farms as well if they can preserve the trees. So basically, we've got to get rid of the perverse subsidies and that are encouraging people to do things that actually are harmful to biodiversity. But even so, just to say that humans aren't being all bad in our world. We're actually creating habitats for lots of species, and we are conserving species, and we are. I think a good way of thinking of this is we are the planet's noosphere, its thinking component, and we can help protect the planet from asteroids. That's a very simple way in which the dinosaurs couldn't do anything to stop an asteroid hitting Earth, but we could. So sometime in the future, there's none headed our way just now, but if some very big asteroid like the dinosaur one was going to hit Earth, say there's one that's got a 1,000,000 to 1 chance in 4479. So without humans, there's no chance. If it in that 1 in a million chance was extraordinarily unlikely. So, but with humans, then, as long as we retain our civilization, it's just not going to hit Earth because we'll deflect it in that very, very remote chance. So, so we are the thinking component of our planet that can protect it in sometimes a very obvious, easy way, comparatively easy. We can protect it from these big asteroids, and we can help preserve these species, and at the same time create habitats for them, as we're doing all over the world. We're doing many things to conserve and preserve the world, and we need to keep that in mind, not just look at the negative all the time. We can do this. We know how to do this. and we know how to do it politically as well as scientifically. So, and this is about all the ways that invasive species can sometimes be beneficial. So it can be habitat and shelter and food for native species. Examples on native tamarisk as nesting sites for nesting birds, and non-native plants in California for native butterflies to lay their eggs and for caterpillars to feed on. They can be catalysts for restoration, for instance non-native guava trees in Kenya supporting fruit-eating bats. It can be ecosystem engineers like sea squirts in intertidal waters in Chile, and they can substitute for something that's gone extinct. For instance, this one giant tortoise replacing one that's gone extinct. And this is an interesting thing you could read about the potential conservation value of non-native species. So, then say food security is increasing year on year, and the roadmaps to get there to feed everyone, mainly because of Africa, is very low, very low. What's the word? Not very intensive agriculture. But I've talked about this as another thing, so I don't think I'm going to go into that. I can talk about that separately. So, which is this? Yes, the UN Biodiversity Report. But I think that might be the. Oh yes. I think I've done enough now. I think I've talked about the main things I wanted to talk about. Yes. Yes, I've talked about everything. So finish there. And so I hope that this helps some of you who've been worrying about mass extinction. We're just at the very start of a mass extinction. So yes, let's quickly look. So we are actually improving the quality of many of the biospheres in some ways with the mixing together of species. The UK is a much richer place in terms of biodiversity. We don't need to think that everything that humans do is negative. Sometimes it's positive. Sometimes we are, even if it's undoing some of our own mistakes, and helping nature in terms of things that happen anyway in other ways. The big cycles in nature as well, by the way, like the way that the Sahara Desert used to be a green savanna. It's every few thousand years it becomes a desert, then it goes back to being like a savanna with bushes and trees and grassland, and then it goes back to being desert in a kind of natural cycle. And we could actually help bring some of that back. We're actually reversing desertification even in the Sahara parts of the Sahara Desert. So there's lots and lots of that going on as well. So yes, about how the extinction. So these are all the threatened species, but with the 10% risk thingy, and the main message is we can stop that. We can stop that, and we can do that. These little by little, some species moving that way, some move that way, and we can make them all move that way if we work very hard on a sustainable way forward. So that's my message. So it's just the start of a mass extinction, just the very, very, very start down here where this is just the start of a mass extinction, and we can bring these numbers down and down until the amphibians are just normal background rate of a couple per century of the species going extinct, whatever it might be for that particular species. So for that particular group of animals. So anyway, I hope this helps some of you to put this in perspective. And it's the same with all of them. Just remember, they're talking about it's the start of a mass extinction. It's not yet a mass extinction. it's only talking about, like for instance, 80 out of 10,000 for the birds. Is one of the worst. The amphibians, 146 out of 6,414. And that's what they mean by saying that we're at the start of a mass extinction. And if you look at the papers by the proper scientists, none of them say we're in the middle of a mass extinction. You wouldn't even notice what's happened so far in the fossil record, although we're losing many wonderful species, sadly, but a huge amount remains, and we absolutely can't stop it. So, anyway, I hope this was helpful, and if you're interested to join our Doomsday Debunked group and on Facebook, and then that's to help people who are scared of various things and upset and worried and various things. You can either join us because you're scared and want help, or to help and reassure people who are scared, and also to help with doing things like this. Very much welcome if there be more people who can start doing, so we have debunkers who do this sort of thing, and the more we can get people to start doing especially detailed debunks like I'm doing, anybody out there as basically what you need is a combination of some academic training, or doesn't have to be academic, but good at checking your facts, and then also it helps if you're good at presenting it to the general public and to people. So sadly, I mean, like for instance, people who wrote this paper, and when I was at Oxford, when I was doing my postgraduate, I met lots of people, lots of researchers, and some of them are very good at explaining things, and some are kind of not so good at explaining things to non-experts, and it's really quite it's a different kind of a skill set, really. So you can have one or the other, or both, or neither, and yes. So it seems I'm quite good at explaining these things to people, so quick at reading them, reading the thing, then I write it up, I explain it to things. None of this is my own research. I'm just doing the very best I can to explain to you what I've read in the scientific literature. Basically, I'm like a science blogger. I'm a science blogger in my spare time, not paid for it, volunteer, whatever you call it. And this is basically how I'm helping. Anyway, yeah, so if any good science bloggers there who are interested in writing just the way things are for scared people, and not exaggerating and not clickbaiting, then this is also very beneficial, I think. Help lots of people by writing a few sensible, factual articles, and then seeing if we can, about what's actually happening, what these things actually mean, what the IPCC mean, what IPBES means, what the sixth extinction really means, rather than trying to kind of make it political and activist and say, well, this is what I'm going to exaggerate it in this particular way because I want to get these particular people to act in this particular way. And there's so many things that are like that, where really it's action-based, and they're saying things not because that's the way they are, but because they want people to act in a particular way. And we need people who just explain things as they are without that activist, whichever way you're going, and to help people who are very scared and who just want to know the truth. Anyway, hope that helps.